Alright, in this tutorial what we're going to do is we're going to simulate the external lighting of an internal scene. Just by quickly rendering off the image, what we can see is we've got very little actually visible in the scene. Reason being is because we've got a single light which is basically externally lighting the scene, which is simulating a sun. So I'm just going to quickly rename that. Let's call that direct sun just to start with, so we don't get confused later on. Now let's just have a quick look within the scene to see what we've actually got. And what we've got is we've got an entire the internal environment is entirely enclosed with a single object which simulates the walls with a hole cut for the skylight and an additional couple of holes cut for the side window. So what we have is also an external sky object which is just got a gradient applied to it. So that's got like a self-illuminated gradient applied. So we're going from the lower area here, which is this white area, up through the cyan, up through to a nice vivid blue. So that's applied to that particular hemisphere. So when we actually, if we glance through the skylight or glance through the window, what we will see is obviously a little bit of a blue sky behind it. What we also have is a red teapot. If we just go back to our render, that the skylight's actually situated around this region here. So that's basically the light is actually being shone right down onto the teapot. So we will get some color cast across the room. And also, if I just quickly delete that light and go back to our camera viewport and render that out, we'll see the rest of the elements in the scene as well. We've got some reflection on the teapot, obviously using a ray trace map with a fall off as before, and we've got a green floor and white walls. Now you notice the white walls are slightly uneven in color, and the reason behind that is it's simulating like a plaster effect, like a whitewashed effect, which is, if I just select that particular object, what we've got is, where are you? Just pull it up, walls, here we go. It's basically a multi-sub material. So if I just actually sample that particular material, we can actually see that we've got certain faces which have got certain materials assigned to it. So we've got the ground faces have got the carpet, which is this green material here assigned to it in this particular slot. We've got the exterior, which is the outside of the walls, which has just got a basic material. Just, we're not going to see it, so it's just got a standard material assigned to it. White gloss is obviously for the window frame here, and the walls have got like this kind of very subtle color difference, just to give like the appearance of like a difference in luminance values for the paint. So to assign that, basically what I did was literally just go around and select various polygons to assign these materials to. So just make sure I've undone anything that I've moved accidentally, which I did, I know. Okay, so what we need to do is we need to go through now and I'll just put that light back. Okay, so what we need to do now is we need to go through and illuminate this scene. So what we'll do to start with is we'll trace the light as light tracer or any other GI system would do. We need to basically think how this system will actually work. So first things first is we need to deal with the key light, where the key light is, what it's doing, where it's pointing. So judging by our scene, if we go to the front viewport, we can see that the light is going straight down to the teapot, and it's basically going to bounce light around the scene. We've also got external secondary light from the sky, which is obviously going to come through the windows and illuminate the scene as well. So we need to create, let's think about this. So we've got the one main key light that's going in. We need to create a light in the center of this teapot to simulate a color cast across the scene. We need to create another set of lights for the walls so it's nicely diffused. We need to create another set of lights for the floor because that's green, so that's obviously going to give another diffused color cast as well. And we need to create another set of lights for the external sky, so we need to create a few here and a couple or so around this skylight region here, which are just tinted blue slightly, so we've got a little bit of color cast going through from that. So first things first, what we'll do is we'll go through and we'll create the we'll hit the light, so the light hits the teapot. The first thing we need to do is obviously create a light where the teapot is. So in the top viewport, what we'll do is we'll just create a standard Omni light anywhere in the scene, and then we can align it in a second and rename that, because obviously again there's going to be a lot of lights in the scene, so let's call it Omni teapot. And then because we've obviously got the material assigned to it, what we'll do is we'll grab that color and assign it directly to the teapot. Now obviously, because we don't want the teapot to be self-illuminated by its own light, so what we can do is we'll exclude the teapot from receiving illumination or casting shadows from this particular light itself. So then we can align it to the direct center of the teapot. We're not using the pivot point, we're using the center, so it actually positions it right in the center of it, as opposed to at the pivot point, because the pivot point of the teapot is actually situated right at the bottom. So if actually we'll do it that way, and then we can literally just shift it up vertically. I'm going to take snap off as well and just move it up to about there. Now what we'll also need to do is we'll need to attenuate this light, so starting at 100%, which is going to be roughly around about that region there, and then the end distance is currently a bit too big, so we'll take that down. We'll take that roughly down to about there. Now this light's intensity may be too bright, it may be too dark. We'll find that out once we actually come to the final render, so what we can do is we can tweak that later on. But for the meantime, what we'll do is we'll turn shadow maps on. The size doesn't need to be that big, we can just dial that right down to 256, and we'll put the sample range to about 10 so it's nicely diffused. Okay, next thing we need to do is we need to turn off any specularity. We can kill the soften diffusion edge as well, basically because we don't want any specular highlights casting around the scene from this particular red light, so that can be ditched. Okay, next thing we need to do is we need to create a number of lights. Actually, let's just go back to our render. Let's just have a look at this. So we've got this kind of red cast that's now coming off it. Bit too intense actually. Let's just dial that down to 0.5. Again, we can tweak this later on once we've actually got all the rest of our lights in, so we don't need to worry about it too much right now. Okay, so front viewport, we'll create the additional lights around the scene. Now what we need to do with this particular one is because we have a cavity around the edge of the walls, we can actually position lights. Just create a new Omni light. We can actually position it inside the cavity. Now the reason we're positioning it there and not on the other side will become very, very apparent if I quickly just do this, and I'm going to reposition it there. So if I put in the camera viewport, I'm going to change the color to white, put shadows on. I'll leave that as is for the minute, and then I'll just render. Now you'll notice we've got this white area here, which is basically illuminating from the light on the side of the wall. So if we illuminate our scene this way, what the problem we're going to have is that we're going to have a lot of white splodges around our walls, which we don't want. So what we can do, because the normals of the geometry of this surrounding walls and floor object, one normal's facing that way, one's facing that way, so we basically have a cavity here which we can actually situate our lights inside. Because the normals are facing the opposite direction, the light, as demonstrated in the uplighter tutorial, the light doesn't see an occluding object, it actually sees straight through into the room. So therefore it won't be occluded unless you turn on in the render panel force two-sided. If you turn on force two-sided, then the light will see a flat surface on the side of this cavity and it basically won't illuminate anything. They just illuminate inside the cavity, which obviously we won't see. So therefore we can just make sure I didn't actually turn that on, did I? No, I didn't. That's right, I'm not going mad. Okie dokie. Right, so we've got this multiplier 0.5, and what we need to do is we need to attenuate it slightly. So we'll start it. We'll start it at 0, may as well, and then we'll extend the far range to about do it to about 700. Just so that it extends out. Because we're going to be using instance versions of this light, if we find that it's too bright, then what we can do later on is we can obviously tweak the settings to reduce the attenuation and or reduce the multiplier. So this particular point, what we'll do is we'll rename it on the walls. Let's actually call it walls 01 because we're going to create a lot of them. And also we need to kill the specular value as well, because we don't need specular highlights all over the place, otherwise it's going to look like, you know, Christmas. So next thing is, because we need to fill this wall with lights, we can basically grab hold of this light here and instance it down there. And then let's have a look in the top viewport just to see exactly where we've got our lights now. So we've got a couple there, so let's just shift those back over this region, and then we can instance them a couple of times to populate the side of that wall. So again, back to the camera viewport, let's have a quick look at it. Bit on the bright side. So what we'll do is we'll dial that down, because we're going to have a lot more. We're going to take it down to about 0.1, because this is basically secondary bounce lighting that we're trying to simulate here. Not need to worry about too much about the banding here, basically, because again we can basically diffuse that later on if we need to. Okay, next thing, let's grab hold of one of these lights here, and we'll go through, and in the top viewport we can basically populate this side cavity here as well. So let's go through and grab hold of one of those. So we'll situate one there, instance that, go to the front viewport, and because this cavity is coming across here, what we need to do is obviously pull this back across to this particular region, and then we can instance it down so it's relatively level. Make sure that we've got both of them selected here. Two lights, yeah. And then we can literally instance those across a couple of times, checking in all viewports, making sure that we've actually got this level. Okay, and making sure that it's actually populating the environment. Okay. Next thing we need to do is we need to do this side slanting wall here, which again is going to be almost like a mirror of this particular setup that we've got here. So actually what we could do is we could grab these couple of lights here, grab these lights here, and then instance those across, and we'll do exactly the same with these guys. So that, again, behind the cavity, again checking in the top viewport just to make sure that we have the lights situated in the right location. Now these guys are a bit close to this. There's a cavity here that goes across there like that, so I need to shift those across a touch, and that should fix the problem. So let's just render this out again and let's have a look. So now we're starting to get a nice diffused effect. We're getting some nice tight areas around here and also around these regions here as well. The red's roughly around about right, I would suggest. Maybe just slightly too intense, but we'll worry about that later on. So we're getting some nice tight shadows around here. One thing I will interject with for the moment, if you notice that the edges of these walls look quite good, the reason being is because any hard edges that are actually in here, same with the region around this top of this wall meeting the ceiling, is because all the edges have been chamfered. Any hard edges in your models really need to be chamfered so that you do get like the occasional glint. Say for example around here you get the occasional glint, around the curved surface. If it's too hard, then it basically does need to be chamfered. Okay, next thing we need to do is we need to introduce the illumination color cast from the floor. So again, same kind of principle. We can basically take a single light. We're going to create a new one because we're using new settings. Well, roughly the same settings, but obviously different colors. So let's call that on the floor 01. Turn on shadow maps as before, and what I'm going to do is I'm going to copy the carpet color. Now this is actually using a map in here, so I can literally just pull in. Let's grab that guy, copy that in there. Now you'll notice that even though I'm using Omni lights, which obviously produce 6 shadows, the amount of time it actually takes to render isn't very high. Reason being is because obviously the geometry count isn't very high, and also the size of the shadow map is pretty low. Now if you do have render problems with obviously a lot of geometry in the scene, then obviously you might need to reduce that, or reduce the amount of lights, or change the lights to different types. So for example, spotlights, because in essence an Omni light is literally 6 spotlights if you're only using it in one direction. Like for example, if you're just having it on the floor pointing up, you could basically just have a very wide angled spotlight. Personally, for this example, I'm using Omni lights just for safety, and just for ease of use to demonstrate the purpose. Okay, next thing, let's get these Omni floor lights situated. Again, we'll worry about attenuation in a second, so let's just make sure that we populate this quite evenly. So let's have a look at the environment. What we've got is we need to put a couple, one there, so one about there, and a couple around here as well, just so we're actually filling the space. So let's drop one there. We'll drop one there as well. Let's drop another one, say about here. We'll drop another one here, and then we'll drop another one here, and finally one there as well. So again, what we can do is sort out the attenuation. Again, if we just do a quick render, we've got specular highlights on here, so this is going to look a bit slightly weird, so a bit too green. I'm going to cancel that and turn off specular highlights for starters, and I'm going to drop the actual value to 0.05, I think. And we'll give that another go. So we've got a bit of a colour cast from the green coming across. The red, I think, is a little bit too intense. So it might be, it might be a case of taking this value, dropping it down to about 0.2, but I think what we'll also do is we'll increase the actual attenuation. Let's put that up to about 350. So we get a bit more colour cast into the room, but not as strong. That's looking a bit nicer. Okay, final thing really we need to do within these within this environment is to I think we'll actually blur these shadows a little bit more. So I'm going to take that up to 20, so it's doubled the blurring on the actual illuminate the shadow from the teapot. We'll do the same thing with the floor and with the walls as well. So let's give that another go. Now the problem with obviously increasing the sample range is that you lose shadow accuracy. It does diffuse things quite well, but like any blurring effect, you do lose some kind of shadow accuracy. Like for example, around this region here, we've got a little bit of light area around where the wall meets the ceiling. So therefore, you may want to, you can't really pull that in any tighter. So what you would need to do is to double the size of that and double the size of that as well, and that should pull it in and make it a bit tighter but still have the same kind of blurring effect. But for this instance it's relatively okay. Okay, the next thing we need to do is to simulate the external illumination from the sky. So we've got this light bright area here on the side of the window, so we really need to correspond the light area on the floor, same deal around here, and also on the wall as well, and around this area of the skylight as well, because it looks at the moment it doesn't sit right. So let's go ahead and do that. So firstly, let's concentrate on this particular wall over this side. So in the top viewport, what we can do is create another another light, and we'll label that Omni Skylight 01. Turn on shadows again. As the light is external, we have had to, well, when I created the original scene, I had to basically enclose this entire environment. Now this is one reason why this environment is actually enclosed, because any lights we position on the outside, if the normals were facing in the opposite direction, i.e. if the outside wasn't enclosed, and we could basically just see straight through into the environment. I mean, even though the environment you can see here looks enclosed, if these back walls, if it was just like a box with its normals flipped and then modelled, if the external wasn't enclosed, then any lights that we situate on the outside would leak through the normals facing the opposite direction into our room. So therefore we would have kind of like a strange lighting situation with the sky leaking through the walls. So what we need to do is we'll create a number of these skylights. So we get like a bit of a wide throw. What we'll do is we'll create another few of these guys, and then let's duplicate them another couple of times, and then what we can do is just set the color. Actually, what we'll do is we'll take the color directly from the material. Let's just grab it from there. So right click on that, edit properties, copy the color, and then we can just paste it straight in there. Okay, so again, specular highlights need to be turned off. Let's make sure we actually turned them off on that one, didn't we? Yes, we did. And they're off on these guys as well. Yep, great. Okay, so specular highlights are turned off on that. We've got quite a wide throw on that, so that's okay. The attenuation we will basically set. I'll set it to 1200, so we get like a nice distribution through. Same principle with the other side. Now what I can do obviously is I can just take these 9 lights and then instance those across to the other side, and then rotate them, because I'm using the selection center, which basically takes the axis coordinates of the center of the selection, and then literally rotate them by 45 degrees. Now the reason I'm rotating them is so that, because the shadows actually point up, side, left, right, if you rotate them, then you might get one shadow intersecting with another, sorry, not one shadow intersecting with another one, but one shadow rendered on one object, part of one shadow on one object and part of another shadow on the same object. So you may get some kind of irregularity. So what I'm doing is I'm just making sure that they're roughly pointing the right way, and that should give us a nicer effect as well. So I'm just going to put that roughly about the same region, so we should get some nice cast across the window as well, and some nice diffusion going in. So let's give that a go. Now it's sitting there for a minute, it's actually thinking about calculating the shadows. So now as we render, we should see a lighter area around the window, which we are, but it's not light enough. So what we need to do is obviously increase the multiplier value for these guys. We can either increase the multiplier value or the attenuation, but the thing is the attenuation is quite large anyway, and the light isn't all that far away from the actual window. So I think we'll double that, and we'll give that another go. This is starting to look a bit better. Still could be brighter though. Okay, I think what we'll also do is just make sure that we've actually got the sky excluded as well, so we're not illuminating the sky. I think what we'll do is we'll just turn that up to, turn it to 0.4. Let's just see how bright this comes out. Might be a bit too bright, but we'll have a look. Yeah, it's a bit on the bright side because we've got too much glare on the side of this wardrobe now. That's roughly about right, but there's a bit too much glare there. So I think what we'll do is we'll dial that back down to about 0.25. And I think that's roughly going to be around about it. Again, a lot of the time what you'll actually spend doing is actually mixing and matching lights like this, dialing the settings, tweaking them, just to get the nicest balance between the two. So you get decent shadows, you get decent illumination, don't get too many glary hot spots or anything like that that detract from the overall image. I think the last thing to tweak really is basically the blurring on this particular main key light. So I'm just going to grab hold of the sun. I'm actually going to take that down to about 8. Actually, I'm going to increase that to 2048. Again, doubling 1024, so we get the use to the full memory block, and then re-render it. So we should have now a nicer shadow cast across the ground. Yeah, a lot sharper, a lot cleaner. Okay, now we've actually got our internal lighting system set up. What we can do obviously is animate a camera, which we've already got in the scene, going through the actual scene itself. So we, in essence, we're doing like a kind of walkthrough. So we've got a 100 frame animation here. So what we can do is we can literally just animate the camera going from point X to point Y, or we can basically do like an intermediary stage, so we can do like an arc, kind of looking around the teapot. Two things to animate here, obviously. One is the camera, and obviously the other one is the camera target. Same principle with lights. What we can do is we can actually change the camera type to a free camera, which basically means that we're only animating the one camera, but in which case we are going to have to, if we want to look in a different direction, we have to animate the rotation as well. So therefore, normally I would suggest stick with a target camera because it gives you more control and ease of use. So for this particular instance, what I'm going to do is I'm going to select the camera. Because we have our start position here, I'm going to go all the way through to the end of the sequence. And I'm going to change this particular curve tangent to this particular one here, which basically gives us a ramp up and ramp down. So basically an acceleration and deceleration. So we've got different types. This one's a smooth. This one will kind of roughly guess and try and make it as smooth as possible. For the most part, it works, but it can also create kind of like a yo-yoing effect, or like a it can suddenly just disappear off at a tangent. So if that happens, make sure you haven't got that enabled and you use another one, like for example one of these guys down here. This is a linear effect, so therefore you will basically get like a sharp acceleration, a linear motion, and then a sudden stop at the end. You won't get a ramp up or ramp down in acceleration or anything. It will literally just be a linear motion from one keyframe to the next keyframe. This one is like a digital step, so therefore it will basically sit at one location until the next location keyframe comes along, in which case it will then jump to the next one. This is, like I said, the acceleration and deceleration curve. This one is basically a very, very abrupt acceleration and then a ramp down into like a standard linear motion. These two literally give you the ability to tweak the tangents and how they accelerate and decelerate using the function curve editor, which is this guy here. Now I'll show you that in a second, but for the most part, for basic walkthrough animation, you won't really need to touch these. Using this guy here or that guy will normally suffice. If you have these on by default, you won't normally need to tweak them. Okay, so by default, I'm just going to have this guy on here. So across at frame 100, keyframes only actually kick in when you actually animate them. So therefore, I need to have auto key enabled so that I can then reposition this camera, and I'm going to put it over here. So if I switch back to my camera viewport, and if I walk through, you'll notice I've got quite a bit of a swing around. Now the reason behind that is because the camera target isn't animated in any way, just the camera itself. So it's basically getting very, very close and whipping round. So what I need to do is obviously I need to animate this guy moving to another point of focus, in which case I want it to look at the teapot. So therefore I can start it at the teapot, so it's less of a whip around, and I can also, because I've got the camera target selected still, I can basically move that down so that when we walk around it, it goes from a horizontal view and gradually looks down to the teapot. Now if you have a look in the top viewport, what you will also see is if I go to the motion tab and click on trajectories, making sure I've got the camera selected, you can see this is our trajectory motion. This is the direction our camera is taking. It's a linear path because I've only got 2 keyframes selected in there. So what I need to do, if I want to round this off a little bit, so I want to curve out a little bit more here, so I want to basically go more like this kind of path as opposed to a linear one, what I can do is I can add an extra keyframe in here. Now the problem is if I use this particular keyframe type, what I'm going to have is that the acceleration we're basically going to speed up from this point, decelerate at this point, and then speed up again and decelerate at the end. So if I do that, just as an example, if I just pull that out there, if I look in the top viewport, watch the camera, accelerate, decelerate, accelerate, decelerate. So what I need is basically a kind of smoother transition, a smoother curve here. So if I go back to frame 50, which is our midpoint, I can basically use a number of keyframe types, a number of tangent types here. So I can use a smooth one, which like I say, it's automatic smoothing type. For the most part it works. So we'll just select that and then we'll position that out. Now you'll notice now that the curve is a lot, the actual trajectory is a lot smoother and a lot more curve shaped and not linear as before. So if I play through that, we still have a little bit of a slowdown. If I switch to the camera, we have a little bit of a blip around about this point, which obviously needs smoothing out. So what I can do is if I go back to the top, I'm going to undo the keyframe, go back to 50, and then I'm going to use one of these tangent types here. So I'm going to use this particular one and then pull that out, so it's roughly about midway, play through it, Again, we've still got like a bit of an acceleration and deceleration, which can then be sorted out by, if I go to the curve editor, we can see the actual translation. Now this is obviously the midpoint, and these are the handles. Because we've actually changed the curve type, we've actually got the access to these handles. Now if I just select these guys, because this particular keyframe here has a, if I right click on it, a custom preset type curve, so therefore that's a preset type acceleration, we don't have the ability to tweak it. Because these are using what's called Bechet curves, Bechet handles, it gives us the ability to basically smooth out this kind of animation. We've got nothing. That's the basic x axis coordination translation, z, y. So now what we should have is a lot smoother motion just by tweaking those handles very, very slightly. So when it comes to rendering, if I just render out a single frame, put it at a low resolution just for preview purposes, it will take less time to render. Sorry, it will look relatively smooth. Okay, one thing that we do need to apply to, and this is something that we need to apply to anything that's at default, we need to turn off auto key just to be safe. What we can do is just make sure we've got all the geometry. Just going to select all the geometry in there. I'm going to right click, go to properties and enable image motion blur, so therefore when we're actually moving we do get kind of like a blurring effect. Otherwise it will look very staccato, very abrupt and not very realistic. So make sure we've got motion blur enabled. So if I now render this, the motion blur isn't appearing at the moment, but if I just zoom in, we will see it be applied. There you go, just applied right at the end. It's basically there's two main types of motion blur. One is object motion blur, which is it renders each object numerous times per frame. So in essence you're getting 5 or 10 instances of the same thing in kind of like a banding effect. So if I just give you that as an example, if I change it to object motion blur and render that out, you'll see when it starts that the motion blur is actually applied straight away. It's actually applied in the render straight away. Now the problem with object motion blur is that it takes a lot longer to render, because in essence you are rendering 10 times the amount of detail, the amount of geometry as before, in layman's terms. The benefit of it is that it works with transparent objects. Now what image motion blur does when you have a transparent object in front of something and an opaque object behind it, the image motion blur is kind of like a charcoal effect or a pastel effect. To basically simulate motion blur, the software literally smears the image. So if you have a transparent object in front of an opaque object, the transparent object will basically smear the opaque object, even if the opaque object is traveling in the opposite direction. So now we've got down to the ray trace object. You'll notice now how long it's actually taking to calculate the motion blur, because it's calculating the ray tracing for each motion blur sample. By default there's 10. So now you'll notice it's actually just got down there and stopped. And you might even be able to hear the fan of the notebook working away in the background. So this is taking an exceptionally long time, so I think we'll cancel it right there. go back to properties, put image back on, and then what we can do then is just render off the entire sequence. So I'm going to render this off and save that to your folder. Let's call that tutorial bedroom finished animation walkthrough .avi. It's about long enough. And then I'm going to save it as trusty Cinepack, and then I'm going to render it out. So what I'm going to do now is I'll render this out, pause the video while it's doing it. So we'll see the animation in a second. Ta-ta for now. Go and do a coffee. Hey. Okay, so our render's now finished. So let's go through it and have a quick look to see what that looks like. Now, hopefully this should appear in your in the video as well, if I've got the capture software right. So now what we've got is it may look slightly banding, but that's basically due to the codec that we're actually using, the Cinepack one, and also possibly due to the video compression in the recording software. So we've got this nice smooth camera motion that's kind of arcing round and focusing down onto our teapot. So that's pretty much it for this particular tutorial, and I'll see you on the next one. Ta-ta for now.